Hello, this is Keith Graham from Codasip. I'd like to introduce you to Assignment 11, Checkpoint 1, determining a custom instruction to accelerate the program bubble sort. Let's go to Coda Set Studio. This checkpoint is broken into three parts. The first part is to get a baseline of the performance of your IA model running the bubble sort program. You're going to be actually profiling the program using your IA model, and you will be looking at the results to determine if there is an instruction pair, two instructions that are back-to-back, that can be collapsed into one instruction. Now, if I can perform the work of two instructions in one clock cycle, I will improve the performance of my processor. I will be accelerating the bubble sort algorithm because the total number of instructions to complete the application will be reduced, because the performance of an application is based upon the number of instructions times the cycles per instruction divided by the frequency. Now, assuming that my cycles per instruction are constant and my frequency is constant, if I reduce the number of instructions, the application time will go down, and I've accelerated the algorithm. The third part of it will be actually to get a baseline of the performance of your processor using the CA model. So now let's take a look at each of these parts one by one. I'm in Coda Set Studio. I'm in the workflow perspective. I've in my bubble sort routine. You can see this is my actual core, as I actually call it branch prediction at this point. I've already compiled it. Now I'm going to profile it using my IA model. You can tell that my IA model has finished is at the bottom here. It says printing XML report. That's the profile report. We'll be taking a look at it. You can also see that it says terminal will be reused. Now, if I expand my view profile, you can see here is the profile which I just created. And once again, you can actually close the preview by clicking on this icon or open it up. But I want to get an expanded view in its own tab, so I will click on open in a new window. Now, the first thing you need to do is record the total number of clock cycles, because once again, we're going to do a performance comparison before and after to ensure that your new instruction is accelerating the bubble sort program. Now, once you record that, we're going to want to take a look at instruction pairs to see if we can collapse two instructions into one instruction. To do that, you will scroll down to where we are looking at the details. And if you look at it, there are many tabs here, all the used instructions. But what we're going to do is take a look at the sequence length of 2. If you notice that once I clicked on it, we're going to start seeing instruction pairs, instructions that that the compiler is lining right next to each other. And you can see here is the total count that instruction pair was actually called during the execution of the bubble sort routine, and the percent of all the total instructions. So for example, this very first instruction pair was executed 116,522 times for 5.4% of all the instructions ran to execute bubble sort. Now, in this assignment or this checkpoint, you will learn how to select which of these instruction pairs that you can actually collapse into a single instruction without adding any additional resource, which I mean is like adding an additional port to your register file or increasing the number of pipeline registers and so forth. Now, the third part is we're going to go back to Codasip Studio, and this time I'm going to run the profiler using my CA model. And once my CA model has finished profiling the bubble sort, I will open the very last profile result. You might actually have to refresh this page. If you do, just refresh it and you'll see your second profile result. And you can see it's on my right hand in the preview page, but like I did previously, I'm going to expand it into its own window. And what you're going to want to record now is the number of total clock cycles to complete it for the CA model. Now, the reason why the CA number has more total instructions than the IA model is because we have the issue of control hazards and structural hazards, which effectively make that my cycles per instruction is not 1. Now, you can see that if I go to resource coverage, I can see that I do have some clearing of my pipeline registers due to control hazards and some stalls due to structural hazards. And because of that, my CPI is not 1. My cycles per instruction is not 1. And since it's greater than 1, when I run it in the CA model, my total cycle count will be greater than what it's in the IA model. So make sure you record both the total cycle counts in the IA and the CA model. And in the IA number, you will want to record, once you decide the instruction period to collapse into a single one, that its total count and the percent times that instruction period is executed. Good luck.